Had to pause on this one a little bit because I thought this was a typo. I thought she was wanting us to find the average acceleration, which would be the slope. Wouldn't be a calculus, but that's not it. It's the average velocity. So if you're going to find the average velocity, you have to find out how far you traveled and then divide by how long it took you to do it. Okay, so we got a little bit of geometry to deal with here. From 0 to 4. It's a trapezoid, but we could break it into a square and a triangle if you like. Sorry. There we are. So we got a square right there. All right. So that means if you were traveling backwards at 10 miles per hour and you did that for 2 hours, then you go backwards 20. So that's a negative 20. All right. And then this is negative 10 because it's half of that amount. But again, it's a triangle. So it's negative 10. Okay. And then it's going to ask us to go to 4 to 10. So, I mean, we've got a trapezoid here. We could do a rectangle and a couple of triangles if you like. Remember that the area underneath the velocity curve is telling you how far you traveled. That's easy to understand if you're just going at a constant rate. It just creates a rectangle, but it doesn't have to be a rectangle. So as you can see, so this one is 2 by 15, so that's a 30. And then these two triangles are identical to each other. So half of 15 times 2. So they're both 15s. Okay. All right. So then let's head back down to the problem. So the average velocity from 0 to 10. Okay. So of 0 to 4. So from 0 to 4, we can see that we went backwards 30, whatever the unit of measure is, and it took us 4 to do that. So this one would be negative 30 over 4. Okay, so what is that? Negative 15 over 2, negative 7.5. And again, we don't have units of measure here, so which is a little unfortunate, but that's okay. All right, and then from 4 to 10, that one was from here to here. It was all positive motion, and it was 60, and it took us 6 to do that. So 60. That's how far we traveled. And then your average velocity over that time would be divided by how long it took you to do it. And that was 6, whatever that is. So this one's 10. Again, don't know what the units of measure are. And also, I was expecting it to be slope, but that's okay. Kind of surprised me with that one. So we had to do area. But the good thing is, these were very easy to calculate. The geometry on that was quite easy. All right, total distance traveled by the object. Okay, well, we traveled negative 30 to begin with, but I want that to count not as displacement. I need that to count as actual distance traveled. Okay. And then after we did that, we traveled for an additional 60. Okay. So this would be 90. Now that's not displacement. Displacement would be we traveled backwards 30 and then we traveled 60. So our displacement would be those two added together without the absolute value. Therefore, it'd be 30. So we'd be 30 away from where we started. Yeah. And but that's not what it was asking. It asked what was the total distance traveled. All right. So that would be 90. All right. So then when is the object slowing down? All right. So the object's slowing down whenever your velocity and your acceleration have opposite signs. Okay. Well, that's happening here. You can see as I travel here, I was going backwards, but it slows down to 0. All right. So that's from 2 to 4. And then it doesn't happen again until I get from 8 to 10. Again, opposite signs. That slope is negative and the velocity is actually positive. All right. So there's 2 times where it's slowing down. It's slowing down from 2 to 4 and 8 to 10. Okay. And justify it says. Okay. All right. The object is slowing down on the interval 2 to 4? Yeah, 2 to 4. Because velocity is negative. And acceleration is positive. I'll put a little note there that that's slope. Okay. And once again, it's slowing down again from 8 to 10 for the exact opposite reason. There we go. Slowing down on the interval. 8 to 10. Because exact opposite reason. Velocity is positive. And acceleration is negative. Again, slope. Okay. All right. And then it says, when's the velocity increasing? Well, velocity is increasing whenever your slope is positive. So my slope is positive from 2 to 6. Here we go. Velocity is increasing on the interval 2 to 6. Because acceleration, again, slope. Slope is what I looked at. Okay. All right, and then when does the object move at a constant speed? All right, well, it looks like we've got a couple of those moments. We have these little plateaus. So the constant speed is whenever your slope is equal to 0, acceleration is 0, and that happened from 0 to 2 and 6 to 8. Okay. Okay, the object is moving at a constant speed. On the intervals 0 to 2 and 6 to 8. Because the acceleration slope is 0 on those intervals. Didn't ask for why this time, but decided to put it anyway. Okay, there we go. That took care of example 3 in its entirety. Yay.